Zero and negative exponents is our topic for today, and we're going to start off by just kind of exploring some expressions that have exponents in them, because essentially, guys, there's two rules that you need to know to answer all of today's problems. So let's start off by kind of figuring out what these exponential expressions equal. So you're looking at something like 2 to the 4th on the first one. This is not 2 times 4, it's 2 raised to the 4th power. Now, there's two numbers involved here, and they both kind of have a different name and purpose. The 2, the big number, that's called the base. And then the little 4, that's your exponent. Okay, so again, this doesn't mean 2 times 4. This means the base, which is 2, times itself 4 times. Okay, you could in your calculator do 2 times 2 times 2, or you don't need your calculator to figure this out, but you could multiply it out like that. Or I don't know if you guys know where the exponent button is, but it's this one right here. If you have my calculator, it's that little arrow. That's called a caret button. That means raise it to the power. So if I was going to type this in my calculator, I would do 2 caret 4, 2 raised to the 4th power. And that's just 16, which isn't that outrageous of a number. Same thing, if I wanted to figure out what's 2 to the 3rd, well, it's just 2 times 2 times 2. That's how you'd punch it into the calculator, but that's not that hard to figure out. That's just 8. 2 squared, we know that's 4. And then 2 to the 1 power, well, that's just 1, 2. So there it is, just 2. So none of that's not that complicated, but we are going to be looking at 0 and negative exponents. All of these little exponents were positive. So there's actually a pattern going on here, and notice that they just decreased the exponent by 1 every time. So it was 4, 3, 2, 1. So if I kept going on the list, it'd be 2 to the 0. And then I'd go into the negatives. So let's see if we can figure out what's going to happen there. Sure, I can plug it into my calculator, but like I said, there is a pattern. So if you look at what the answers were every time, it was 16, 8, 4, 2. And if you notice, you're actually just dividing by 2 every time as you decrease the exponent by 1. So let's say that I kept going with that, and I did 2 divided by 2. Well, that would be 1, which is kind of weird because people are going to see 2 to the 0 and automatically say 0. But if I checked it in my calculator, 2 to the 0 is actually 1. And guys, that's our first rule. So let's kind of arrow over. Rule number 1. Any number, doesn't matter what it is, any single number to the 0 power equals 1. 5 billion to the 0 equals 1. Doesn't equal 0, equals 1. Okay, so that's the first thing you got to know. If I kept going on the list, and again, the pattern was I was dividing by 2. Well, 1 divided by 2 is 1/2. A half divided by 2 is a quarter, and 1/4 divided by 2 is 1/8. I could keep going, but I'm going to stop. There's another way that I could write 1 over 2. And maybe this will help us pick up the pattern. So really, when I get into the negative exponents, all I'm doing is saying 1 over this 2 squared thing, or 1 over 2 to the 1, because 2 is just 2 to the 1. 4 is just 2 squared. The denominator here is 8. Another way to write that is 2 to the 3rd. So if you notice the pattern here, they're just taking this base and exponent combo, and they're putting it over 1 and making it positive. So that's exactly what the second rule is. And this one is kind of obviously a little bit trickier than just memorizing anything to the 0 power equals 1. But to move the exponents across, you move the exponents across the fraction line to make them positive. So let me give you an example of what I mean. Let's say it's 4 to the negative 3rd. Well, what does that equal? Anything to the negative power is going to be a decimal. And I could plug it into my calculator and see it was a really gross decimal. We're not going to rely on our calculators because we want our answers to look a little bit nicer. So I'm going to ask that you write your answer as a fraction. So here's how you would simplify that. Think of it as a fraction, because to make this a positive exponent, you're going to move this whole little term here across the fraction line. So I'm going to take this whole 4 to the negative 3, and I'm going to put it on bottom. And when I do that, it turns into 4 to the positive 3. And then you just have a filler of 1 on top. Okay, so the second thing you need to know is, because a rule is you cannot have negative exponents for something to be simplified, so you're going to have to make your exponents positive, and you do that by just moving them across the fraction line. So if it's on top, move it to the bottom, and if it's on bottom, move it to the top. We are going to practice this a lot. Okay, the directions are going to be super basic, super straightforward. It's just going to say simplify the expression. If it says simplify, here's your steps. Definitely get these in and follow them as you work. So the first thing you want to look for is 0 exponents, because that's pretty easy to take care of. You're going to make all the 0 exponents equal 1. So we'll get to the examples in a minute. I almost jumped ahead of myself, but anything to the 0 power equals 1. Take care of that. Then you're going to move your negative exponents across the fraction line to make them positive, because your answer is not simplified until you have all positive exponents. Your third step is you want to evaluate numbers, and I'll give you an example of what I mean by that. If you've got something left that's like 3 squared, that's not the best possible answer, because I know that 3 squared is 9, so I would want to evaluate that base to the exponent, and I would want to say 9 as my best answer. Okay, this just takes practice, so let's go through it. Number 1, again, follow your steps. I don't have anything raised to the 0 power, so step 1 does not apply, but I do have negative exponents. And if I want to be simplified, I can't leave a negative exponent. I don't know who made up that rule, but somebody decided it's not simplified if there's a negative exponent, so you got to get rid of it. Okay, and I told you to move it across the fraction line, so I'm going to take that 4 to the negative 4 and put it on bottom. So there will just be a 1 on top, and it's going to turn into 4 to the positive 4 since I moved it. Step 3, I said to evaluate numbers, so that would be this like 4 to the 4th. I want to figure out what that actually is, and it's 256. So I'm going to put that number on bottom, and that is the best answer, 1 over 256. Again, sure, you could write this in your calculator, but that is not the best way to write this. A much more concise, accurate answer is the fraction, not the decimal. Okay, so you got to show me your skills without the calculator here. You'll see why on the back. Okay, if you look at 2 and 3 at the same time, they look almost identical. The only difference is number 3 has parentheses, number 2 does not. The parentheses make a big difference, especially when it's squared. So here's the difference here. And again, you could double check this in your calculator to see the difference. Let me show you first though. If the parentheses are there, let's do that one first. If the parentheses are there, if you square something, that means you multiply it by itself. So the parentheses are there, and the parentheses are keeping the negative and the 6 together. So this problem just means, hey, take the negative and the 6 and multiply it by itself. So this would be negative 6 times negative 6, which is positive 36. When the parentheses are not there, the negative is almost like not even attached to the 6 yet. This is almost just like a little negative 1 out front. And you can think of it as like a negative 1 that's being multiplied by 6 squared. And guys, if you think back to order of operations, you do exponents before you do multiplication. So I'd have to do 6 squared, which is 36, and then I'd multiply it by negative 1, which would actually give me negative 36. So watch your signs. You got to be really careful. And if you typed it into your calculator with and without the parentheses, it would show you the difference. These two common mistakes happen here, but we're going to practice this along the way. All right, I'm actually going to skip number 4 because there's a lot of examples here. It's kind of all the same thing. You'll get lots of practice later. I have the power to do that. You can too. All right, number 5. Look at step 1. Anything to the 0 power equals 1. So that's a huge number. It's just there to throw you off, but it's all raised to the 0 power, so it's actually just 1 as my answer. Number 6. I know we'd be quick to say, oh, this negative 10.263 is being raised to the 0 power, so I'm going to say 1. But this kind of goes back to example 2. When there's a negative out front there, it's kind of like you're doing negative 1 times that 10.263 to the 0. Okay, so be careful. This 10.2630 to the 0, or 10.263 to the 0 power, that's 1. But then you've got to multiply it by the negative 1, so the final answer is actually negative 1. Okay, and if there's no variables, I mean, yeah, verify it in your calculator. See if the right answer is what you got. That's negative 1. Okay, you get to use your calculator, so like, why wouldn't you check it? Here's why we need to know how to do this without the calculator though. Because guys, obviously I can't type y to the negative 3 and x to the negative 4 into my calculator. I have to have these skills in my mind so that way I can figure out things with variables. But if it says simplify, your steps are still the same. And you still can't have 0 exponents and negative exponents for something to be simplified. That's why this is called 0 and negative exponents. Okay, so think about zeros first. I don't have anything to the 0 power, but I do have negative exponents, which I know I need to fix. Okay, we said that if you move things across the fraction line, that makes your exponents turn positive. So I need to move both of these terms, they're separate, to the bottom to turn these into positives. I'm taking everything out of the top, so that means a 1's just going to stay there. And on the bottom, it'd be y to the positive 3, x to the positive 4. I have no numbers to evaluate, so I'm done. That's my answer. Okay, on number 2, I do have something to the 0 power. And again, I'm thinking of my steps here. Look for 0 exponents. M to the 0, that's just 1. So just go ahead and cross it off because it's not going to do anything. The only other problem, and the reason this is not simplified, is because there's these negative exponents. So this n to the negative 1 needs to move down, and this guy also needs to move. So you just move it across the fraction line to make it positive. So y to the 5th is going to come up top. When you write your answer, just be real careful you write the correct term like on the correct side of the fraction line. So y to the 5th, positive 5th, is going to be the only thing on top. And on bottom, I'm going to have n to the positive 1, and w squared is still there. So that's my final answer. Okay, for number 3, I like to throw this example on there because people will make the mistake of they'll take this whole thing, 3ab negative 2, and they'll move it to the bottom. But realize, like, each part of this, the 3, the a, and the b, they're all separate. They actually all have their own exponent. So the b's exponent is real clear. It's negative 2. The 3 and the a, if they don't write the exponent, it's actually a 1. And since it's a positive 1, leave those two alone because you only need to move something if the exponent's negative. So actually the b, that's the only thing that needs to move to the bottom. Leave 3a on top, and it'd be b to the positive 2 sitting on bottom. All right, 4 is a fun one. I don't have anything to the 0 power, so don't have to worry about that. I just need to take care of all the negative exponents. All those things need to move. So the 12 needs to move down, b needs to move down, and d needs to move up. Okay, so again, just be really careful what goes where when you write your answer. A squared is still on top. D to the positive 8 is going to come up top as well. On the bottom, we usually write the number first, so I'm going to put 12 to the positive 2 first. And then I'm going to have b to the 3rd, c to the 6th. Kept it in alphabetical order, why not? Okay, last step. You should always evaluate numbers if you can. So here's what I'm talking about. 12 squared, that's 144. So to make this the best possible answer, I'm going to say 144 b to the third c to the 6 on bottom. Okay, I want you guys to try 5 and 6. Okay, and I'll check those next time and see how you're doing, see if you got them right. All right, last example here. It's still the same idea. 0 exponents equal 1. Move your negatives to make them positive. But the difference is the directions. It doesn't just say simplify. It says evaluate each expression when m equals 4 and t equals -2. So they're going to give me an exponential expression here, and they're going to tell me what m equals and what t equals. Steps for these types of problems, because these can be tricky. The first thing you want to do, don't even think about the fact that I know what m equals and I know what t equals. You want to do first what we just did up here. You want to simplify this thing. Okay, what that means is, think of the title of the notes. That means there should be no 0 and no negative exponents. Do that first, okay? So look at number 1. Here's what I'm going to do first. I don't see 0 exponents, but I do see negative ones. I know that 3 and m both have an exponent of 1, so the only negative one is the t. So I'm going to move that down. Okay, so I simplified this. People are too quick to do these problems, and they forget to do that part first. But I make you do that part first because it makes the problem so much easier. Okay, once it's simplified and you have no 0 or negative exponents, then you want to go ahead and plug the numbers in for the appropriate variables. Okay, so now think about the fact that they told you that m was 4 and they told you that t was -2. Okay, so let's plug those numbers in. So on top it'd be 3 times m is 4, use parentheses. And on the bottom, t is -2. If you don't use parentheses when you plug a number in, you will get the sign on this wrong, which will make the whole thing wrong. Okay, because remember, when I put this into my calculator, if my calculator would work, there we go. If I have the parentheses, and if I don't have the parentheses, it's going to give me a different answer. Okay, so be careful. -2 squared with parentheses means -2 times -2, which is +4. All right, so on the bottom, that equals 4. 3 times 4. On the top, I have 12. And I know that 12 divided by 4 is just 3. Okay, I want you guys to try number 2. See what you get. Your answer should just come out to be like a number. Could be a decimal, could be just a whole number. You'll have to see. Okay, so try that one. I'm going to finish it off with number 3 here. I want to simplify first. So for me, I know that means I got to bring t to the -3 down to the bottom. You do not have to bring -8 to the bottom. It's okay if a base number is negative. It just can't have a negative exponent. But I know that -8 has an exponent of 1, so that one's okay. Okay, so leave the base number alone, that's fine. Just bring t to the third down to the bottom so it's positive now. Now I'm going to plug in my numbers for my variables. So on top, let's see, m squared, m was 4. On bottom, t was -2, and I used my parentheses. Sure, you could go to your calculator from here. So that's -8 parentheses 4 squared. So on top, that's -128. On the bottom, use my parentheses, and I plug it in like that. If you guys need help plugging in, maybe you have a different calculator than me, just ask me next time in class, and I will help you figure out how to work your calculator. And then guys, the last step, this is just a division problem, so I'm just going to divide these two numbers, and my answer would be 16.